This lesson is on the metric system and metric prefixes. Our standard here is I can work with measurements, and you can see the 4 learning targets. In this video, we'll really focus on those first 3. The converting of the units we'll work on more in class and in a separate video. So jumping right in here, our first learning target, we want to be able to demonstrate the difference between quantities and units. So those two terms, quantities and units, often get confused, and in order to differentiate between the two, I think just a very simple question can help us understand which one is which. So a quantity, that is what is being measured. So if I give you an object, I say measure its length, measure its mass, or an event. I want you to time how long it takes a certain person to run a mile. Those would be quantities: length, mass, time. Volume is another example. Speed, velocity, those are all quantities. The unit is how we are measuring that quantity. So for example, for length, you might measure it in meters, in centimeters, in inches, in miles, depending on what it is you're measuring. To measure time, you might use the unit of minutes, seconds, years, hours. Those would be units of time. For mass, you may use a unit grams, kilograms, milligrams. Those are units of mass. So the quantity is what we're measuring. The unit is how we're doing that measuring. So for each of these terms here, pounds, length, time, etc., I want you to ask yourself, is that a term of a quantity, meaning what we're measuring, or it is a term for a unit, meaning how we're measuring it? So I want you to pause the video, write those terms down, and then list quantity or unit. Just write it out. Once you've done them all, play the video, see how you did. Okay, you've had a chance to do this. So for pounds, pounds is a unit. If you're measuring the weight of something, which is actually a force, the unit you would use might be pounds. You wouldn't go up to someone and say, what is your pounds? Okay, you might say, what is your weight, or what do you weigh? And the unit for that would be pounds. Length, that's a quantity. Okay, if you measure the distance from one point to another, you're measuring a length. You wouldn't say, I measured the table and I measured the length of the table and it was 27 length. Okay, it would be 27 inches, for example. That'd be the unit. The quantity is the length. Time is a quantity. That's what you measure. Velocity is also a quantity. That's what you measure. Milligram is a unit. You would measure something's mass using milligrams. Meters per second, that is a unit. That would be a unit of speed or velocity. Weight is a quantity. Okay, again, not a unit, but you might say, what does the textbook weigh? What is the weight of the textbook? That would be a quantity. And then finally, kilometer or kilometer, however you want to pronounce it, that is a unit. Okay, you measure something's length. You might measure the distance from Lake Mills to Northwood. You might measure that in kilometers. All right, so that's our first learning target, demonstrating the difference between quantities and units. Now we want to specifically talk about metric units, and we want to identify some units for the quantities of length, mass, time, and volume. So here's the thing. The scientific world uses metric measurements. Being that this is a science class, that's what we're going to use. We're going to use metric measurements. Now I know a lot of us aren't as familiar with those as we are with our American standard measurements. That's okay. Throughout the course of the year, we will get used to the metric. So here I'm just going to list quantities, and we'll give a definition for those, and then we'll list some of the American standard units that we're more familiar with, and then we'll list some metric units that maybe we're not as familiar with for those same quantities. So in your notes, go ahead and make a table like you see there with 3 columns: quantity, standard units, and metric units. Okay, so for the first one here, we have length. So for the quantity of length, well, first of all, a definition of length. Length is just the distance from one point to another point. That's all it is. Some standard units that many of you are probably very familiar with will be things like inches, feet, miles, yards. Those are standard units of length. Metric units would be like a meter, a centimeter, a kilometer, a millimeter. Now notice I did put the unit meter there. I made it bold. I put it in italics. The reason I've done that is the base unit for that quantity. Meter is a base unit in the metric system. What that means, isn't of our concern at this very moment. We'll deal with that later in the class. For mass, mass is the amount of matter in an object. Now, in the American standard system, we don't really have a very common unit for mass. You might be thinking pounds, and I think I mentioned this earlier. Pound is actually not a unit of mass. Pounds is a unit of force. The unit of mass in the standard system is actually called the slug. It's not pounds. Many of you have probably never heard of that unit slug before. That is okay. It's not one we ever deal with in this class, just kind of a for-your information thing. However, in the metric system, there are many units of mass, some of which you have probably heard of or you're familiar with. Things like the kilogram, the gram, the centigram, the milligram. Those are all units of mass. And again, notice the base unit there, it is the kilogram. And also notice I've put the symbol for each unit with these units. The reason being is we want to be very familiar with the symbols, because in science we often communicate using symbols, not entire words. The next quantity we want to be familiar with the metric unit is time. So time is just how much time passes between two events. The thing about time, there are no different metric units of time than what we already know. The units that we already use, hours, minutes, seconds, years, etc., those are the same ones that we use in the metric system. Notice the base unit for that is the second. And notice its symbol is just the lowercase letter s. And then finally, volume. Volume is the amount of space an object takes up. So for example, if you had a basketball, if you want to know how much space in the universe it takes up, you would measure its volume. So some standard units of volumes would be things like gallons, pints, fluid ounces, teaspoons, tablespoons, cups, quarts. Those would all be standard units of measuring volumes. Metric units would be something like the liter, the milliliter, or the centimeter cubed. Notice the centimeter, that's a unit of length. Okay, centimeter is a unit of length, whereas centimeter cubed, we multiply it 3 times, becomes a cubic unit, length, width, volume. Now we have a unit of length, width, and height. That becomes a unit of volume. So we can see that we can turn a length unit into a volume unit by making it cubic, by multiplying it by itself 3 times. Alright, for each of these, I want you to tell me, is the metric unit what the appropriate quantity is. So your options are A, mass, B, length, C, time, D, volume. So pause the video, ask yourself, is the gram, is that a unit of mass, length, time, or volume? And just answer A, B, C, or D for each of those, and then play the video when you're done. Alright, the gram is a unit of mass, so A. Second, that's a unit of time, C. Milliliter, notice milliliter, not millimeter, that's often confusing for students. Milliliter, that's a unit of volume, D. And then a year, that's a unit of time, C. I'm not sure why my answers are not lining up there with the questions, something about the formatting. Anyway, going to 5 through 8 here. Meter cubed. Now notice it's meter cubed. If it was just meter, it would be length. But because we've cubed it, we've taken meter times meter times meter. So length times width times height or depth, whatever you want to call it. That gives us a volume unit, so D. Kilogram. That is a unit of mass, so A. Kilometer. Notice not kilogram now, kilometer. That is a unit of length. How far is it from one point to another? So B. And then meter, also a unit of length, so B. Alright, we have identified metric units for the quantities length, mass, time, and volume. We now want to describe how metric prefixes change units. So metric prefixes. Why use the metric system? Why is it better? Why does science worldwide almost exclusively use the metric system? Well, here is why. The sizes of units can change. They change by powers of 10 using these metric prefixes we're going to learn about. This is known as a decimal system. Now, unlike what we are familiar with the American Standard System, like there are 12 inches in a foot, and there are 3 feet in a yard, and there are 5,280 feet in a mile, which means there's 1,760 yards in a mile. We don't have to have a bunch of random numbers to memorize like we do in the American Standard System. It's all based on powers of 10. And because of that, all that ends up happening is we move the decimal place in order to convert units from one prefix to another. So here's an example. Let's say the length of this line here, of this solid black line, this dark black line, let's say that's 1 meter. If I take that line and I divide it into 10 equal parts, so I have 10 equal parts there, I have now divided that line into lengths of a decimeter. Each of these small parts is 1 decimeter. Notice the symbol there, lowercase d for the prefix deci, and then still m for meter, which is 1/10 of a meter. Because there are 10 of these, we can count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of those in the whole meter, so 1/10 of a meter is a decimeter. So in other words, the prefix deci means 1/10. Now note, that's whether we're talking about decimeters or decigrams or deciliters. It doesn't matter. It's 1/10. So a decimeter is 1/10 of a meter, or 0.1 meters. A decigram would be 1/10 of a gram, or 0.1 grams. A deciliter would be 1/10 of a liter, or 0.1 liters. So notice the prefixes apply to every unit. Unlike with our American Standard System, I have to know all sorts of different units for all sorts of different quantities. I just need one set of prefixes for every quantity. It works so much easier. Let's keep going with this. Now this here is the same schematic or same model I had on the previous slide, where I have my 1 meter, this whole thing represents 1 meter, and I've divided it into decimeters, where from one of these black marks to the next is a decimeter. But now I've taken one of those decimeters and I've divided it into 10 even smaller portions, where I've divided that 1 decimeter into 10 equal parts. So if I blow that up, if I zoom in just on that 1 decimeter, so now the length of this whole line represents 1 decimeter, and I divide it into 10 equal parts like I did up here, I have now gone from 1 whole meter, so again this whole line up here is 1 meter, and I divide it into 10 equal parts, and each of those parts is 1 decimeter, and I divide each of those decimeters into 10 equal parts. We now have 1/100th of a meter, because if I were to do this to all 10 of these parts, I would have 100 marks, because there's 10 parts in each of these decimeters, 10, 10, 10, 10, 10, etc. That would give me 100. That gets me to a centimeter. That is 1/100th of a meter. So each of these small marks up here is 1/100th of a meter, blown up here, as you can see here, to this size, and that is 1/100th of a meter, or called a centimeter. So the prefix centi means 1/100th. Now I'm doing the same thing that I just did before. So now this entire length represents 1 decimeter, and 1/10 of that from this line here to this line is a centimeter. I now divide that into 10 equal parts. And so here is my centimeter line. I'm going to divide that into 10 equal parts. That's going to get me to a millimeter. So a millimeter is 1/1000th of a meter, because I took 1 meter, I divided it into 10 parts to make a decimeter. I divided one of those into 10 parts to make a centimeter. I divided one of those into 10 parts to make a millimeter. So I divided it by 10, divided it by 10, divided it by 10. That gets me to 1/1000th of a meter, 0.001 meters. So the prefix milli means 1/1000th. And again, these prefixes can be used for any unit, not just for length, not just for meters. I can use millimeters, milliliters, milligrams, milliseconds. It works for any unit. So what about prefixes to make units bigger? We've looked at these deci, centi, milli. They all divided the meter into smaller units, smaller length measurements. Could I make it bigger? The answer is yes, I can. There are lots of different prefixes to make it bigger as well. Now we're not going to look at all of them, but here are 3 of them. The prefix deca, which has the symbol DA, means 10. So if I had a decameter, notice the difference between that and decimeter. A decameter would be 10 meters. So if I had 10 meter sticks, put them back to back, the entire length would be 1 decameter. If I had 100 meters, that would be a hectometer. The prefix hecto means 100. So if I took 100 meter sticks, lined them up end to tail, tail to end, whatever you want to say, that length would be a hectometer. The term that you all are most familiar with is the prefix kilo. Kilo means 1,000. So that would be 1,000 meter sticks lined up end to end, and that entire length would be 1 kilometer, or kilometer, if you want to pronounce it that way. So the question then is, how many meters are in 1 kilometer? Well, that would be 1,000. Since kilo means 1,000, there are 1,000 meters in 1 kilometer. A couple of review questions here. Just answer the question as each one pops up. How do metric prefixes change units? Well, metric prefixes, they change the size of units. They make them bigger or smaller. What does the prefix centi mean? Milli, kilo, deci. And these happen to be the ones that you will need to memorize. So the centi, milli, kilo, deci, you need to memorize what these prefixes mean. Centi means 100th, or 0.01. Milli means 1,000th, or 0.001. Kilo means 1,000. And deci means 1/10, which is 0.1. So we've looked at how we describe metric prefixes to change units. We're not really going to look at this last learning target on this video. We'll work more on that in class and on a future video lesson.